Hey guys, welcome to Daily DSA Practice and welcome Orgodeep into this mock interview. And as you know
Mhm.
that I will be recording this session for uploading on the YouTube. Do you have any concern on this part?
Oh no, I
Cool.
am okay with that.
Cool, Orgodeep. Thank you. So, Orgodeep, let's start with the basic introduction of yours and then we'll come up with the question and try to solve it.
Cool. Okay, so myself, my name is Orghodip. I am from West Bengal, India. Currently, I am doing my BTech in the field of computer engineering from NIT Kurukshetra. Currently, I am in my fourth year of my BTech, and my hobbies include practicing coding, playing chess, playing football, hockey, etc.
Cool.
And that's all.
Thank you. Thank you. So, Argadeep, can you share your screen? I'll tell you a question, and generally it would be one question around 40 minutes, and then after
Cool.
that we will go with the feedback. So, can you share
Cool.
your screen and we will go ahead?
Yeah.
Okay.
Hmm.
So here the question is, a binary string is monotone is increasing, right?
Hmm.
And the binary
Hmm.
string, you know, right? It consists of 0 and 1,
Yeah. Yeah.
right? So
Hmm.
monotone increasing means all 0 first and after that 1. And it
Okay.
is a possible that all zeros are still a monotone increasing string. All 1 is also a monotone increasing string, right?
Cool. Got it.
So
Hmm.
what you have to do is you are given a one binary string, right?
Yeah.
It should not be in a monotone. It could be 0 1 0 like this, right? So
Okay.
what you
Hmm.
have to do is you have to flip either 0 to 1 or 1 to 0 and make that string monotone increasing.
Okay.
So you
Got it.
what the question is, you have to find out the minimum number of flips you have to
Hmm.
do to make the string monotone increasing. Okay,
Okay.
so for example you can write one example. Let's say example is 0 0 1 1 0, right?
Hmm.
So
Yeah.
here it can be converted to 0 0 1 1 1. The last 0 can be flipped to
Yeah.
1. So how many
So
number of flips? Output is 1.
one. Yeah. Yeah.
So you understood the question?
Yeah, yeah, I understood.
Okay,
I fully understood the question.
yeah,
So
go
for
ahead.
example, if this is the input, so in this case, uh, okay, so do I also have to output the final string or only the minimum number of flips only?
Minimum number of flips only.
Okay, okay. So in this case, the answer will be zero, right?
0, right?
Only, and for this case also, the answer will be
0,
uh,
say.
zero. And let's say, okay, so all these are clear. And can the input string be an empty string?
Let's say that we at least have a string. It would not be an empty. Let's say that.
Okay, so it will at least have
At least.
only one
Correct.
character, right?
Right.
At least one. Okay, cool. So we have to make this string monotonically increasing. So basically what we have to do here is that we have to make, let's say that up till a particular index we have to make all the elements zero, and then let's say that for in this example up till the fourth index we have made all the elements zero, and after that we will make all the elements one. Once we have started up one, we cannot make any further element zero, right?
Mm-hmm. Right. Right.
Cool. So the initial approach which I can think about is that the initial approach is that, let's say like I will do something like, okay, so for each one of these, so for each one of these characters there are two possibilities, right? Either it can be zero or it can be one,
Right.
right? And so since now if the length of the string is, let's say, n, so then there will be 2 raised to the power n, uh, uh, the uh, total combinations of string, right?
Correct.
uh, so and so what we can do is that we can generate all those combinations of string by using some recursive function, and then we can, for each of those, we can calculate, we can first check if it is a valid monotonic string or not. Yep. And then if it is valid monotone increasing, then we can check like the how many steps are required to convert this by just this simple condition. Let's say the original string is A and the another string is B, and since both of them have the same length, so we will just check answer plus equal to A of I plus A of I not equal to B of I. That is, if the the characters at the corresponding indices are not same, then we have to flip it, and we will do this only for these, only for those strings which are monotonically increasing, right?
Sorry, I lost it. What is A and B?
Okay, okay. I am actually generating all possible combinations which can be obtained for a string of length n.
Through recursion.
Yeah, yeah, through regression, right?
Okay, okay.
Okay, and after that, what? And after that, let's say that we have obtained a final string.
Mm-hmm.
Okay. Let's say that after the recursion is complete, we will get us an list of strings,
Mm-hmm.
right? List of strings we will
Okay,
get,
okay.
right? And so for this list of strings, for each of the string in those list of string, we will check, firstly check if that string is increasing, and if it is increasing, then I will call a compute, then I will call a calculate the cost required, which will give me the cost to change the original string to my current string, and we will do this for each of these strings, and for the string the and for that string which gives the minimum number of flips, that will be our answer. uh, did you get it?
Again, okay, I got your point, but still, yeah, we can little bit optimize it also.
Yeah, 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 yeah,
Yeah.
yeah, 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 yeah,
So,
yeah, yeah, yes, 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 yes. I think I have got it. Like in the recursion itself, while we are making the while we are making the transitions, we can just keep another variable
ca-
instead of storing the string actually, which will keep the
minimum.
which will keep the minimum number of steps required up till the ith index.
Correct, correct.
Right.
Yeah. So the
So
time complexity which you have told, yeah, I am totally okay with this approach, recursion approach. So time
yeah,
complexity you told is 2
yeah.
raised to power n. What is the space complexity?
Okay, so the space complexity of this will be like at max the recursive stack, the size of the recursive stack can be n. So the space complexity is O of n. Uh,
Mm-hmm.
uh, just let me think once. The recursive stack, and we are maintaining another variable to keep the count of the strings. Yeah, it is O of n space complexity.
Okay. No, but so see with an so when the is time complexity is 2 raised to power n, but let's say each combination, right? So there are two
Yep.
possibilities. For each variable,
Yep.
there are two possibilities. So recursion will go
Yep.
into
Yep.
both the path, and as
Yeah,
you
yeah, no,
know
no,
that,
no. Yes, yes. Okay, okay.
and the
So
recursion
you are right.
recursion will use the internally stack, right? So that
Yeah,
also a space it required, right? So for one character, there are two different ways. So recursion will go into two different paths. So how it would be only big O of n?
okay, okay, okay. So just let me explain this part.
Mhm.
Let's say that initially we have an empty string. Now we are going to let's how to, just a second. Let's say this is an empty string. Now when we are going towards the recursion of one, sorry, let's say we chose the first index as 0, right? And then we will compute the recursive part. Just a second. So after this, what will happen is that from this zero it will go to another zero. Then from this zero it will go to another zero. I am just saying an example, and let's say that this is the end of the string, right? So up till this point, the recursive stack use is O of n only, right?
Mm-hmm. Yeah.
Okay. Now let's say that here the string is complete. So from a recursive function, we will go back to this call, right?
Mm.
So here, this zero will no longer be in the recursive stack. It will be
Right.
popped out from the recursive stack, right?
Awesome. Okay, cool. So now also tell me that 2 raised to power n time complexity is good. Can you just tell me like can you little bit optimize this time
Yep,
complexity?
yep, yep, yep. So what we can think about is that we can think about another approach, like uh, we can fix let's say we can fix a particular index. Okay, let's say we can fix a particular index. Okay, just let me do one thing. Let's say that this is our string. Okay, so what we can do is that we can what we can try to achieve is that in our sorry, just a second. In our final answer, it will be something like, okay, it will be something like 0 0 0 and then 1 1 1, and these zeros can be, and this count of zeros can be 0, and also this count of ones can also be 0, right?
Mm-hmm.
Yep. So what I will do is that I will try to make all the characters up till a certain index 0, and I will try to find the cost required for this. And all the characters from the index I plus 1 to the last index, I will try to make them 1, and I will calculate the cost required for that. And after that, I will just add those two costs and get and let and get a value for this particular string, and then we can update our global answer. Let's say, for example, in this case, it is 0011. Okay, it's not a good example. Uh, let's say that this is our example, right?
Okay.
Okay, let me just shorten it once so it will
Huh.
be better.
Yeah, yeah.
Yeah. So initially, what I will do is that initially I will try to make all the characters 0, right?
Okay.
So for that, the cost record will be 2. Okay.
Okay.
Now what I will do is that I will try to make, okay, so here let's say we are using one based indexing, right? So here if we are so here 2 for up till 0 index, which is basically the index before the first index, right? Did you get here?
No, I didn't get this. Up till 0 index. So
Okay,
2
okay,
2 is
okay,
like you told all you make the everything
okay,
0.
okay. Oh, okay, 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 okay. So just wait for 1 second. Okay, so these are the indices, right?
Hmm.
1 2 3 4 5.
Okay. Okay.
Okay, since I'm doing one mesh indexing,
Hmm.
so the answer will be 2. So for up till 0 index, we are making all zeros. That is basically in the left of this one index, right?
Okay.
So the left of one will we can assume it to be of 0 index, right?
Okay.
So up till this 0 index, the answer will be 2.
Why answer is 2? Because you haven't traversed it right till that.
Yep. So uh, I am just saying you the approach, uh, and then I will explain to you how will I achieve this thing, right?
Okay. Okay. Yeah. Yeah. Go
Okay.
ahead.
So here up till one index, that is up till this, it is 0 and all others are 1. Okay. Huh. Okay. Sorry. Actually, sorry. I missed one thing. Here up till 0 index, all are zeros, right?
Yeah. That's
Yeah, and from the 1 till the end, all will be 1, right? So the answer in this case will be uh, only, because I have to make this 0 1, this 0 1, and this 0 1, right?
No, why?
This 0.
Uh, why can't you make 1 1 as a 0 0?
Can you please repeat again?
No, and see, I got confused here. Like, why the answer is 3?
Okay, okay. No, no, no. I am actually checking all possibilities, right? So our in our final answer, it will be some zeros, then followed by some ones, right?
Correct.
Okay, correct.
Or,
So
or,
here,
or final answer, it could be all 0, or it could be
yeah,
all
yeah,
1.
yeah, 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 yeah. So here, up till zero index, all zeros. Okay, I am making up till zero index, all zeros, and after that all one. Right, doing the same thing, especially this thing. So for this, for it, the answer will be this is 0. Now I have to make these two uh, zeros 1, right? So the answer will be 2. Cool. So similarly, I can check for all of the possible integers, right? Okay. So now, up till now, are you
Yeah,
okay?
yeah, yeah. Till now I am with you.
Okay. So now, how to achieve this? Name this function at minimum steps required, and let's pass it. Okay, so we are vector. Let's pass it a string, and let's pass the string as reference so that the string don't get copied. So here, what I will do is that since the string, so firstly, what I will do is that I will find the length of the string, and n equal to s dot length. Right. Since a string is always zero based indexing, and I am doing it in C++, so for that we will also keep our soft1 array as uh, zero based indexing only, right?
Mm-hmm.
And now what I will do is that I will traverse in the array from the front, from the right towards the left. And because here we can do one thing, like instead of regularly calculating, uh, uh, instead of calculating the number of ones in a suffix again and again, let's say that up till this index, just let me explain a bit. So let's say that I have my answer, that is the half one of this is 1 2 3 4. Like I have half one of 3, right? So I can update half one of 2 equal to if if s of 2 equal to is not is equal to 0. If it is 0, then this value will be 1. S of 2 equal to 0 plus half of 3. Are you okay with this?
No, okay.
This will be half 1. It's actually meaningful. Okay.
FS of
So
I
we can, okay,
equal
okay.
to
So here we can do something like this, like half 1 of I equal to s of I equal to 1, sorry, equal to 0, because if it is 0, then it needs to be updated. No, no, no. Oh, sorry. I am actually wrong in this. We are just calculating the number of ones, right? So I am actually wrong here. So here the condition will be s of 2 equal to 1 plus half of 3, right? Because if it is, because we are saf is storing only the count of ones in a suffix. So if this is 1, then only it should get incremented, and we will just add it with the suffix of the I plus 1 index. So here it will be s of I equal to 1 plus let's say if I plus 1 is less than n, we can use here the operator here, then sub 1 of I plus 1 else 0, right? So after calculating this whole thing, we can just run okay, another for loop, let's say from the 0th index till the ith index, and let's maintain one answer. Since the maximum number of operations required will be at most n. So let's initialize our answer with n only. Right. The answer equal to n, and here what I will do is that, okay, so here what I'm trying to do is that up till I minus 1 all zeros, and from I to n minus 1 all 1. Are you okay with this?
Yeah, currently I'm okay with it.
Cool. And we will also maintain current zeros. Okay, let's name it pref zeros, right? Let's name it pref zeros 0, and this pref zeros will give me the number of zeros up till the index I minus 1
Okay.
when I'm at the index I. So here I am at the index 0. So pref zeros is giving me the number of zeros up till the index I minus 1. Okay.
Hmm.
So here we can calculate to achieve this kind of structure. So what will be the minimum steps equal? Mean steps required equal to, we can do that will be ref zeros plus saf, okay, plus, okay, it should be n minus I, that will be the length of the suffix starting at index I, minus, you can do saf 1 of I. So this is actually, okay, let's do it, let's keep another variable so that it will be easy. So saf zeros will be this thing. Saf zeros will be this thing, and also in ref ones will be I plus, okay, so it will be I minus ref zeros, right? So answer the minimum steps required, with, since we are making up till I minus 1 all zeros, so we have to make all the, we have to convert all the pref ones to zeros. So it will be ref ones, and we have to convert all the saf zeros to ones. So saf zeros, right? And we will just update our answer. Answer equal to minimum of answer, comma mean steps required, and then after that what we have to do is that we have to update the pref zeros, because for the next index this our this current ith index will also be included. So pref zeros plus equal to s of I equal to 0. So if it is 0, then we will increment it, otherwise not.
Cool.
And then finally we will print our answer.
Sure. Okay. So Argodeep, like I'm good with that. So can we stop sharing the screen so we can discuss?
Okay, cool. Okay, just 1 second. The space complexity of this will be O of n. So since we are requiring another half array for storing the count of ones, and the time complexity will be O of n, since we are just using two for loops, and each containing n iterations.
Right. That time in line.
Cool. So
Can
let's
you?
stop this. Yeah.
Just a second.
Yeah.
Okay, let's. I have. So let's go on the feedback part.
Cool.
So first of all, on the positive part, Argodeep, the use cases, the way you have found out, right? Edge cases and all. That's very good. Like, so no, like very good on that part. The brute force recursion approach you explained, the time complexity and the space complexity, the way you have explained is also very good, right? So
Cool.
that's all perfect.
Cool.
And I can definitely tell that you are a very good coder, right? But here the one thing I want you to improve is you do not spend too much time on explanation, right? See today, see you to be honest, at one after one point of time, I got totally lost it. To be honest,
Okay.
sub one, what IJ, right? And I
Uh,
am know that you are trying to explain me harder, right?
hmm.
And I was as an interviewer, I was also trying to understand it, but after a one point, I totally messed it up, right? So
Okay.
what I want you to do is that you do not waste too much time, your valuable time, on over explaining to the interviewer. Ki interviewer should know, should understand it. So you have to little bit optimize this explanation part. Come up, you can create one sub fun array and show how it is filling. Finish, right?
Yep. Yep.
Because I also have a follow-up question. Can you do it without even space complexity of one?
Okay.
Right? But
Okay.
if you see that we are already 40 minutes, we couldn't ask it, right?
Yep. Hmm.
From interviewer side, you take more time. But if you're
Hmm.
from point of view, you are taking more time in explanation to interviewer. He is not able to
Yep.
understand. So you are also right.
Hmm.
Interviewer also right. So what I'm trying to
Hmm.
say is that don't try to explain too much. Try to
Yep.
keep it little bit shorter. Come up with a just create one array, sub one, and explain with that visually rather than
Hmm.
writing and explaining. Another thing is the coding which you are doing. Definitely you are a good coder, but try avoiding take variables name like s n I like this one,
Okay.
right? So give proper name index, array index, and all, right? And instead of s, take a proper like it's a which string, input string, right?
Okay.
And what was that? N. I don't know what is n. So
The length of the string.
yeah, okay. So just say that like this ni doesn't means anything into the when your code goes to the production thing from the production
Okay.
way. So
Yep.
this
Yep.
so right. That's pretty much from my side, and I'm thank you very much, Orgodip, of the recording here.